this these rules we can use to find, these derivatives of these more complicated functions. So here we have the tangent line. We want to find the tangent line of this more complicated function. So we're going to differentiate that. So I want to find the tangent line at x equals pi over 2 and x equals 2. So I need there are two different functions with two different tangent lines. Okay, so here, first of all, I'm just going to find the y-coordinate for this function, because I need that y-coordinate to get a tangent line. So I'm going to have sine of pi over 2 is 1, 0 plus 1, so y equals 1. And here, when I plug x equals 2 into this function, I'm going to get 2 times 3, which is 12, minus 18 is negative 6. Looks like y equals negative 7. Just double checking that. 12 minus 18 minus 1. Okay, so that's negative 7. Okay, so then I want to have, for this first one here, this is a quotient. So I need to apply the quotient rule. So f prime of x, I'm going to apply the quotient rule. So there's my numerator, and there's my denominator. So I'm going to apply my rule. So I differentiate the top. Okay, I don't differentiate the bottom, so that's cos x plus 1 minus the top, so sine x, so the top is undifferentiated, then the derivative of the bottom, which works out to be negative sine x. Oops, that's going to be in green, sorry. Okay, so negative sine x. And then the denominator should be cos of x plus 1 all squared. Okay, so when I simplify this out, I'm going to end up with cos squared x plus sine squared x, which is really just 1, plus cos x. When I multiply cos x times 1, that's my numerator. I have an identity here, and I end up with cos x plus 1 squared. And when I simplify this further, I actually get 1 plus cos x in the numerator, and cos x plus 1 squared in the denominator. So this even further simplifies to cos x plus 1. Okay, so just double checking my signs. Yeah, that should be negative, negative, so that is a positive. And there's my derivative. So I want my derivative, or my slope, at pi over 2. Okay, the slope at pi over 2 is going to be, well, cosine, that's going to be, cosine of pi over 2 is 0, so I get a slope of 1. So there's my slope. Okay, the equation of my tangent line, and maybe I'll make sure I do this in a different color here. So the equation of my tangent line, my first tangent line is y equals 1 x minus pi over 2 plus 1. Okay, so there's one tangent line. So the second tangent line is going to be from the g function. So I'm going to differentiate my g function. I'll do it over here. G prime of x, this one's fairly straightforward. So I get 6x minus 9. I want the slope at x equals 2. So at x equals 2, I get a slope of 3. So there's my slope. Okay, I'll call it m2 and n1. I can write my equation of that line now. Okay, with that equation of that line, I'll write it as y equals 3x minus 2 minus 7. Okay, so those are my two lines. I can now solve this. I'm just going to graph this and solve this one. Okay, so I'll show the graph of this on Desmos.